While Google Earth represents a fascinating application of technology, particularly in its ability to render detailed geographical imagery and provide a virtual exploration experience, it is important to acknowledge that its primary function and utility fall outside the scope of electrical engineering or related technical disciplines. The core principles and functionalities of Google Earth are rooted in computer science, data visualization, and network communication, rather than the fundamental laws and principles governing electrical circuits, power systems, or electronic devices. To elaborate on the aspects of Google Earth that are not directly relevant to electrical engineering, it is useful to consider the following points. Firstly, the application relies heavily on satellite imagery and aerial photography to capture and generate its visual representations of the Earth's surface. These images are collected by specialized sensors and cameras mounted on satellites and aircraft, and then processed and stitched together to create seamless, high-resolution maps. The processing and manipulation of these images involve complex algorithms and techniques from the field of computer vision, which are not typically covered in electrical engineering curricula. Secondly, Google Earth utilizes sophisticated data compression and streaming techniques to efficiently transmit and display large amounts of geographical data over the Internet. These techniques are designed to minimize the bandwidth requirements and latency associated with downloading and rendering detailed maps, especially for users with limited Internet connectivity. The optimization of data transmission and display is a key area of research in computer science and network engineering, but it is not a primary focus of electrical engineering. Thirdly, the application incorporates a variety of interactive features and tools that allow users to explore and analyze geographical data in different ways. These features include the ability to zoom in and out of maps, rotate and tilt the view, measure distances and areas, add annotations and overlays, and create custom tours. The development and implementation of these features require expertise in user interface design, human-computer interaction, and software engineering, which are not typically considered core competencies of electrical engineers. In summary, while Google Earth may be an interesting and engaging application of technology, it is not directly related to the principles and practices of electrical engineering. Therefore, a detailed discussion of its functionalities and features would be outside the scope of a technical discussion. However, to provide a broader perspective on the relationship between technology and electrical engineering, it is useful to consider some examples of how electrical engineers contribute to the development and advancement of technologies that are related to geographical data and mapping. For example, electrical engineers play a crucial role in the design and development of satellite communication systems, which are used to transmit and receive data from satellites orbiting the Earth. These systems rely on sophisticated radio frequency RF circuits, antennas, and signal processing algorithms to ensure reliable communication links between satellites and ground stations. Electrical engineers are also involved in the design and development of GPS receivers, which are used to determine the precise location of objects on the Earth's surface. These receivers utilize signals from a network of satellites to calculate the user's latitude, longitude, and altitude. The design of GPS receivers requires expertise in RF engineering, signal processing, and embedded systems. In addition, electrical engineers contribute to the development of sensors and instruments that are used to collect geographical data, such as LiDAR systems, which use laser beams to measure the distance to objects on the Earth's surface. These systems are used to create high-resolution 3D models of landscapes and urban environments. The design of LiDAR systems requires expertise in optics, lasers, and signal processing. Finally, electrical engineers are involved in the development of power systems and energy storage solutions for remote sensing platforms such as drones and unmanned aerial vehicles (UAV). These platforms are used to collect geographical data in areas that are difficult or dangerous to access by traditional methods. The design of power systems for drones and UAV requires expertise in power electronics, battery management systems, and renewable energy technologies.